In this one, I'm going to prove that this statement is true, where the domain is the real numbers. Remember, the real numbers are all decimals. And the statement that I'm going to prove is that for all x, for all real numbers, if that number squared, if x squared is less than itself, then x has to be less than 1. All right, let's state our assumptions. Assume that x is a real number and x squared is less than x. All right, so we've stated our assumptions. Now we want to prove our conclusion. So to kind of figure out what to do, you might off to the side write, so the little scratch work here, I'm going to erase this in a moment. You might write x squared is less than x. This is what we get to assume. And we want to, okay, so this is our assumption, and now where we want to get to is x is less than 1. And so you might ask yourself, how do I manipulate that to get that? Aha, I see it. If I divide both sides by x, I'll get that. And that's the right line of reasoning. But now you want to ask yourself, did I gloss over anything? And the answer is yes. I did gloss over some things. And the problem is, there's two issues. The first issue is what happens. So the first issue is, what if x is equal to 0? If x is equal to 0, then we're dividing by 0, which we can't do. Can't divide by 0. Remember, anything divided by 0 is undefined. So that's a problem. Another problem is, what if x is negative? Right? Remember, if x is negative, then we have to flip the order of the sign. When you multiply or divide by a negative with an inequality, you got to flip the sign. So that's a problem. So our strategy in this proof is we're going to show that it's impossible for x to be 0 and it's impossible for x to be negative. So let me write these two things down here, just to keep them in mind. So what we're going to do is we're going to show that x cannot be 0 and that x cannot be negative. So I'm going to put a line through that, meaning that x cannot be negative. We're going to show those two things. Once we establish those two things, then we can play this game where we divide both sides by x, because we know that we're not going to divide by 0 because x is not 0, and we're not going to have to flip the sign because x is not negative. Okay, so to do this, what we're going to do is we're going to say, well, what happens if x does equal 0? If x equals 0, then 0 squared is less than 0, right? Remember, this is our assumption. We're assuming that. We're assuming that, right? Why do we get to assume this? Remember, we're proving a statement of the form P implies Q. If P is false, then it's true anyway, so we may as well assume it's true. Okay, well, if x is equal to 0, then by our assumption, the thing in red there, we know that 0 squared is less than 0. So 0 is less than 0, which cannot happen. Right, this can't happen. 0 can't be less than itself. So we found something that can't happen. What was our assumption? We asked, well, what would happen if x equals 0? If x equals 0, well, then we find something that can't happen. So x does not equal 0. Okay, we've taken care of that one. Now we say, okay, well, what happens if x is negative? So what happens if x is negative? If x is negative, right, we don't want x to be negative, right? That's what we're trying to show there. But we're saying, okay, well, what would happen if it was negative? And what we're going to do is we're going to find something else that cannot happen. And so then x cannot be negative. Remember, all mathematical statements are true or false, right? So if this can't happen, then the negation must be true. So if x is negative, then using our assumption again, x squared is less than x is less than 0. Now x squared, remember, x squared is always positive. So 0 is less than x squared is less than x is less than 0. And 0 is less than 0 again. Again, which cannot happen. So x is not negative. All right, so now we've established that x is not equal to 0. I'll put these in blue. We've established that x is not equal to 0 and x is not negative. So now using that information, we can modify our assumption, right? We can multiply both sides by 1 over x, because we know we're not dividing by 0. And when we do that, we don't have to flip the sign. We know we don't have to flip the sign. And that's the proof. We've now proved our conclusion that x is less than 1.